Hi Math C students, here are a few examples to help you if you are struggling with the last 4 problems on homework BC numbers 17, 18, 19, and 20. These are some similar problems where you're given a trig function of an angle equal to a value and another trig function being positive or negative and asked to find some other trig functions of that same angle. So the idea here is that if I know that sine of theta is equal to 2/3, I can draw a triangle, a right triangle, where since sine is opposite over hypotenuse, I can say that the opposite is 2 and the hypotenuse is 3. I can find the third side using the Pythagorean Theorem. So let's say this is x squared plus 2 squared equals 3 squared. X squared equals 9 minus 4 is 5. So x is equal to the square root of 5. Then I can use this triangle to find tangent and secant. So tangent of theta is opposite over adjacent, which is 2 over root 5, which is 2 root 5 over root 5 if we rationalize. And secant of theta, well, cosine is adjacent over hypotenuse, which is root 5 over 3, so secant is the reciprocal, which is 3 over root 5, which rationalizes as 3 root 5 over 5. The last thing, maybe not the last thing, but the other thing we need to do is know what quadrant we're in. So if sine is positive and cosine is negative, that means we are in quadrant 2. So that means tangent's going to be negative. So tangent of theta should actually be negative 2 over root 5, which is negative 2 root 5 over root 5. I messed that one up a little bit. That's actually negative 2 root 5 over 5. Apologies. And then secant of theta should also be negative because cosine is negative. So it should be negative 3 over root 5, which is negative 3 root 5 over 5. Let's do another example. So in this case, we have tangent theta equal to negative 4/5. Sine of theta is negative as well. Again, I'm going to draw the triangle. I'm not going to pay attention to the negative sign. I'm just going to say tangent is opposite over adjacent. And I'm not going to worry about the fact that one of these is negative. It's not a big deal. And then I'm going to find the third side. The third side is not 3, right? This is not a 3, 4, 5 triangle because the hypotenuse should always be the longest side. So Pythagorean Theorem, I'm going to call this, you can call it whatever you like. I like to use x. So here, 5 squared plus 4 squared equals the hypotenuse, which is x squared. 25 plus 16 is 41. So x is going to be the square root of 41. I can also look at I like to look at the quadrant last, to be honest. So cosine of theta is adjacent over hypotenuse. So cosine of theta is 5 over the square root of 41, which rationalizes as 5 root 41 over just 41, not the square root of 41 on the bottom. And then cosecant of theta, so I know that sine of theta is 4 over root 41, so cosecant should be root 41 over 4. I don't need to rationalize this one because there is no radical in the denominator. Finally, looking at the quadrant I'm in, so if both tangent and sine are negative, well, I know that tangent is negative in quadrants 2 and 4, because it's positive in quadrants 1 and 3. And sine is negative in quadrants 3 and 4. So it's got to be this one. Right? It can't be this one, it can't be this one. That's the quadrant where both sine and tangent are negative. So cosine is positive. So this is going to be positive 5 over root 41, which is positive 5 root 41 over 41. Cosecant should be negative because sine is negative and cosecant is the reciprocal of sine. So that should be negative root 41 over 4. All right, that's how we do problems like that. Hope this helps.